All right, howdy! Today we're going to talk about implicit differentiation. It's kind of a almost magically fun thing that goes on. So, first of all, you have to know that some equations can be solved explicitly for y. Oops. So for instance, if I have the equation x plus y equals to 3, then I can solve that explicitly for y as y is equal to 3 minus x. Okay? So if I wanted to do derivatives or whatever, it'd be easy now. But some equations only have implicit solutions. For example, which one do I have here? Here's one. Y squared plus e to the y is equal to 1 plus x cubed. Now there's a general theorem in mathematics called the implicit function theorem, and most of the time it'll tell you that there is a function. Y is a function of x, but it's essentially impossible to write it down explicitly in terms of giving the formula. So it determines a function y of x, but good luck trying to find it. So you would think that'd be the end of the story. Can't find an explicit solution. Oddly enough, it isn't. Even though we can't find a formula for what y is explicitly, we can find a formula for its derivative, and that's called implicit differentiation. So this is done, I think, best by an example. So find y prime of x if y satisfies this equation we just wrote down. Y squared plus e to the y is equal to 1 plus x cubed. Okay? Now, the trick for doing implicit differentiation is to remember that this y is implicitly a function of x. So if you think of this in your head mentally, you should always be thinking the equation really looks like this. Y of x squared plus e to the y of x is equal to 1 plus x cubed. And if you think of it that way always mentally, then you'll get this no problem. All right, to find y prime, what you do is this. First of all, step one, you always will take d by dx on both sides. So for us, if we do the derivative over here, we see that this y squared is a chain rule problem. The outside function is x squared, so its derivative is 2x, and we have to evaluate it at y. We have to plug in y. And then times the derivative of the inside, that'll be y prime. And then e to the y, well, that's a chain rule problem as well, where the outside function is e to the x, so the derivative is e to the x, but we evaluated it at the inside. And then we multiply by the derivative of the inside. Well, that's just y prime. And then take the derivative of the right side, we get 0 plus 3x squared. Okay, so let's plug in all this stuff. We get 2y prime plus e to the y prime is equal to 3x squared. All right, step 2 after taking the derivative is to solve for y prime. And it's a theorem that this is always doable. So factor out the y prime from both terms on the left side. You get 2y plus e to the y left over. And so that lets us solve for y prime as 3x squared all over 2y plus e to the y. All right, that's really just so fun. Remember, way back here, we had no chance of solving for y, but there was some function that solved for it. We just couldn't write it down. And even though we can't write it down, look at that. We can write down explicitly its derivative. It's just really a lot of fun. All right, ciao.